Hello, my dear students. Welcome you all. This is your B V Reddy sir. A great news to all of you. So, in GATE 2024, 7 AIR 1 ranks from Unacademy students only. So, you can have a look at now here. Electrical, Computer Science, ECE, 𝐂𝐤𝐼𝐴N, PI, and NM. So all these 7 AIR ranks from Unacademy students only. Now it's time for you can start your serious preparation with the Unacademy, and to provide the best coaching and all, we are here. And additionally, we are providing the flat 50% of discount. Have a look at now here. In the Unacademy subscriptions, we are providing the flat 50% discount only. Have a look at now. And this offer, which is valid only up to 30 July only. And you can have a look at now here. The top educators team you can find in the single frame में आपको मिलेगा. To avail this opportunity, you can use a code of B V Reddy. You can use a code of B V Reddy to avail this great feature. So we can have a look at now here. The top educators team is in one team. Next, have a look at now here. So we are providing the plus subscription and iconic. So plus subscription के लिए 9999, iconic के लिए so 15,999 only. Have a look at now the top educators team. Right, we are starting the new batches. We are starting, as I told now, from the 21st, July. That is from Sunday. I am starting the EMFT. I am starting, and that is 9 p.m. You can enroll for this course by using the code of B V Reddy. Do join the sessions to have a great learning experience from me. Right. Chalo, let's start our discussions. These are the new batches we are starting. You can have a look at now the top educated stream you can find, I think so. Look at now. These are the list of books for ECE and electrical. These books will be delivered to your home within the 15 days for the iconics के लिए. चलिए आज का सेशन हम शुरू करेगा. So have a look at now here. See the problem here. Find the equivalent circuit of the following combination of batteries and also find the current in the external resistor. They ask to find the equivalent combination. So you can see now here we have a two cells. We have this is EMF, this is E1, this is my R1, this is E2, and this is R2. And here this is my external resistor, this is R. And have a look at now here what they given now here. E1 is how much you tell me now? 5 volts. And R1, which is equal to what, tell me now here? 1. Next, what else they given now here? Second cell EMF, which is given us what, tell me now here? 3 volts. And R2, which is given us what, tell me now here? 2 ohms. And the capital R is equal to what, tell me now here? 1. External resistance. Now they are asking to find equivalent. Now tell me now effective EMF. The effective EMF, I am simply calling it as what, tell me now? EE. Effective EMF. So this could be given as what, series connection. And tell me now it is aiding or opposing. Now you can see now here for this is a positive, negative. The negatives are connected. So what I can call it is now it is opposing. So this is what we can say now here, series opposing. In case of a series opposing, tell me now what is the effective EMF. You tell me now here E1 minus E2. That is bigger value minus smaller value. So that is 5 minus 3, which is given as what, tell me now here 2. So this is the effective EMF of the combinations. Next, the resistors, equivalent resistance R effective. If I say it should be given as these two resistors are in series now. So it is R1 plus R2. How much is value? 3. So means effective EMF is 2 volts and equivalent internal resistance is 3. We need what tell me now here? The current through the external resistor. This is I, which is given as what we can say now here. The effective EMF by, so effective internal resistance plus external resistance. So this value which is given as 2 by what we can say now here 3 plus 1. So how much is value? 1 by 2. Next, find the equivalent circuit of the arrangement. Also find the current in the external resistor. Now you can see now here. Now here if I call this is my cell 1 E1, this is R1, and this is what tell me now E2, and this is R2. This is the external resistance. Now you tell me now here we have two cells has been connected in parallel. So you can have a look at now EMF from the first cell is given as what tell me now 5, and internal resistance is given as what tell me now 1. Second cell EMF which is given as what tell me now here 3 volts, and internal resistance is how much you tell me now here 2 ohms. Now this R is what tell me now here 1 ohm. Now you can have a look at now here. So how this connection is happens now here, aiding or opposing. So this is a parallel opposing. So here this current which is flows this direction, this current flows this direction. So means it is what we should call it as a opposing. What type of connection? Parallel connection. So we'll call it as what tell me now here? Parallel opposing. In case of a parallel opposing, so that is tell me now effective EMF which is given as what we can say, tell me E1 R2 minus E2 R1 by R1 plus R2. So you can tell me now what I'll get this effective EMF, that is E1 R1, 5 in E1 R2 means 5 into 2 10 minus 3 by R1 plus R2, so that is equal to 3. So means what we can say now here 7 by 3 volts. The equivalent resistance, the two resistors are connected in parallel. Equivalent is given as what we can say R1 R2 by R1 plus R2. So how much this value tell me? So that is 2 by 3. Now the current to the external resistance which is given as what we can say now effective EMF by internal resistance plus capital R. So how much this value tell me now? 7 by 3 by, so that is 2 by 3 plus 1. So we'll come it as what we can say now 7 by 5. Okay, 7 by 5 is answer. Next one. The figure shown B1, B2, B3 are three bulbs rated as 200 volts 50 watts, 200 volts 100, 200 volts 25 watts given. Find the current through each bulb and which bulb will give more light. So bulbs has been connected in series. In series connection current is same. So they given the power, what they given, that power is called as a rated power. They given as what tell me? A rated power. A rated power. Now you can have a look at now here power P, rated power. So which is given as what tell me? Which is equal to V squared by R. The rated power is what tell me? V squared by R. So from this we can able to get the resistance now by giving the power given and potential is given. V squared by the P rated. Now you can have a look at now here. So bulb 1, for this bulb 1, we will find the resistance now here. How much R1 is given as V square by R. V is how much, you can tell me now here, 200 into 200 by power. Power is how much, you tell me now here, 50. So how much will come here? This is 50. So this is 8 now. So how much is value? 1600 ohms. Next, for the second bulb B2, we can find the resistance R2, which is given as what, tell me? So V square, V is 200, so 200 into 200 by rated power. Power for this one is how much? 100. So I will come it as what, tell me now here? 400 ohms. Now you tell me for B3, that is third one, B3. So that is resistance R3, which is given as what we can say, tell me? 200 into 200 by what, tell me? So 25. Yes. 1 second. This is 8 only. 8 for 4 now. 54 only now. Sorry. Then how much is value, tell me? It will come it as 800 only. This is 25, 25, 8. So now this is 1600. Now, so that means the network which will be given as what we can say here, tell me? It will become series connection containing the 3 different resistors. The bulbs we are replacing with here resistors only. The bulbs we have replaced with the resistors. So how much is value, tell me now here? Supply battery given as 200, and this is what is this R1 value given as what, tell me now here? 800, and this R2 value given as what, tell me? 400, and R3 value given as what, tell me now? 1600. So we'll find this current I. So what is the total net current passing through the circuit now here? Equivalent resistance. What is the R equivalent now here? How these are connected in series? How much is value? 8 plus 4, 12. 12 plus 16, isn't it? So it is 12 plus 4, 16. This is 800 plus 400 plus 1600. How much is value, tell me now here? So this is 16, 2000, 2800 now. Right, this is the equivalent resistance. Now from this we can get the current. So how much is current, you tell me now here? Supply, which is the 200, by resistance is how much now? 2800. So we'll get 2 zeros will get cancelled. So this is 214. So how much is current, you tell me now here? 1 by 14 amps. 1 by 14 amps. Now they are asking to find which bulb will glow more light. So glowing of a bulb will depends upon the power. Whichever the power is more, that bulb will glow more brightly. So you can see now here which bulb will glow more. Now series connection, current is same as we know power, which is equal to V into I. Current is same. So that means brightness will depends upon the potential. As we know, potential depends upon the resistance. Potential depends upon the resistance. So from this, what we can say here, they given this R1, R2, R3. So you see this thing, which is more? R3 greater than, R2 greater than, no, R1. So this is R1 greater than R2. So from this, what I can say, tell me now here, power. I can say P3 greater than, P1 greater than P2. So that means which power is more now here? Bulb 3 power is more. Thereafter second question B1, last B2. Right. Take the next question. Two bulbs A and B are rated as like this. So bulb 1 rated as what, tell me now? Bulb 1 is rated as the power which is given as 100 watts, comma 220 volts. And the second bulb which is rated as what, tell me? 50 watts, comma 110 volts. The two statement among the following is. So now look at now here. So let us find the resistance now here. R1. R we have seen R is equal to V square by P. So means what we can say now here? V1 square by P. That is P1. So tell me now here resistance of the first bulb is V1 square, which is given as what, tell me now here? 220 into 220 by P1. Power is how much, you tell me now here? 100. So how much will come? The R1 is 22 into 22. So means 484 na? 484. Next coming to the resistance of the second bulb. That is V2 square by power P2. So tell me now resistance of the second bulb is a V2 square. V value how much? So 110. So this is 110 into 110 by what, tell me now? This is 50. So how much will come? This is R2 value, tell me. So simplify this thing, 1 0 will get cancelled. So it will come it as what, tell me? 242. How much is value? 242 ohms. Now they are asking to find a resistance of A is more than B. Yes, the resistance of the first bulb is more than B only na? Yes, correct only. The current drawn by A is less than current drawn by B. Current drawn by A. So here they didn't mention what type of connection. What type of connection they didn't mention. If it is series connection, same current. If it is parallel connection, then the statement is correct. But they didn't mention what type of connection. Right. So we cannot say second statement is always true. Next, the third one is when the two bulbs are connected in series to a 220 volt source, bulb B in series connection, bulb B glows brighter than A. When they are connected series, whichever having high resistance, that will glow high. So then which is high resistance now, tell me? R1 has high resistance. R1 will glow brighter compared to V1. A glows brighter. So that's why this is wrong statement. Only the first one is correct. B is also wrong statement. It is not always true. If it is a parallel, the statement is correct. If it is series, the statement is wrong. Next one. 4 5 ohm resistors are connected together along the edges of a square. A 20 volts battery of negligible internal resistance is connected across a pair of diagonally opposite corners of a square. The power dissipation in the circuit is. They are saying here, so 4 5 ohm resistors are connected to form a square like this. They are forming a square. They given that each resistance is given as what element of here? 5. Each resistance is given as, this is what you tell me now here, 5. Next. So now here they has connected a battery of 20 volts. Negligible internal resistance is connected across a pair of diagonally opposite. So means they are saying that, so if you have considered this thing, they connected, so diagonally opposite point they connected like this. They connected as like this, diagonally opposite points. Now this value given as 20 volts. Now they are asking to find the power dissipation in the circuit. The power is nothing but, so this is nothing but, if I say this current is I, power is given as V into I. So the EMF into I. So you can tell me now here how these two resistors are connected. You can see now here these two are connected in series and this also connected in series. Thereafter it is a parallel. So this value, how much you tell me now? 10 ohms. This value, how much it is at 10? 10 10 is a series now. Yeah, it will be, sorry, 10 10 parallel will becomes 5. So finally R equivalent of the circuit is how much we can say this is 5 ohms. Equivalent resistance is 5. From this I can able to get the current now. The current is given as 20 by 5, which is equal to what I can say, tell me, 4 amps. The power dissipation, the power which is given as what we can say now here. So this is I square into R equivalent. I square, that is what we can say now, 4 square into R equivalent is 5. So this is 16 into 5 now. How much this value, tell me? 80 watts. Next. Two 10 volts 220 volt bulbs are connected in series across 110 volt source. The net power delivered by the source is, the power delivered by the source is, they are saying that two same cells, same bulbs, they given two bulbs, they are connected in series. So let us find the resistance of each bulb. Both bulbs are same only now. Resistance of a bulb is given as what, tell me now? V square by P. So that is R is equal to V value is 220. 220 into 220 by P. How much the P value, tell me? P value given as 100. So that means we'll come it as what, tell me now here? 484 ohms. So this is the resistance. Now what we need to find, you see, the net power delivered by the source. We need to find. Here the two resistors has been connected in series, right? So here two bulbs are series means those bulbs we have converted into a resistance form. Now this R value, how much you tell me now here? 484. And this R value, how much it is? 484. Now this supply is given as 110 volts EMF. And now they are asking to find the net power. If I say this current is I, now you can see this thing here, how the equivalent resistance, now these two are connected in series only now. So that means what we can say now here, 484 plus 484. So the equivalent resistance is how much we can say here, that is 968 ohms. Okay, so from this we can get the power which is given as what we can say now here, I square into R equivalent. So power P, I value how much? So I value we calculate. So let us find the I also. I is equal to what we can say, tell me now here. So that is EMF by total equivalent resistance. EMF is how much? 110 by equivalent resistance is how much? 968. So simplify, get this answer. This is what tell me now here. 110 by 968 whole square, equivalent is 968. So the power is what tell me now here. 110 into 110 by 1968 will get cancelled, 968. Simplify, you will get this as what tell me, 12.5 watts. So option B. Next, the EMF of a Daniel cell is given as 1.08. When the terminals of the cells are connected to a 3 ohm, the potential difference across the terminals was found to be 0.6. The internal resistance of the cell is what they given now here. So they are talking about some cell. The cell EMF is given. They didn't mention about the resistance. Any cell will have certain non-zero internal resistance. The EMF which is given as what tell me now, 1.08. Internal resistance is something. So terminals are connected in series to a resistance of 3. Now they are connected to a some other resistance. The resistance of this which is given as what tell me now here, 3 ohms. They are saying the terminal potential. So this potential, they are saying this as V, this value given as what tell me, 0.6. Now since we know this potential, then we can get this current, we can get now. If I say this current is I, so this I is equal to, the potential is 0.6 by resistance, we can say now. 0.6 by 3 will come it as what we can say now here, 0.2 amps. Means this current is how much you tell me now, 0.2 amps. So this is 0.2, this is also 0.2 only now. So then this current is also 0.2 only. This current is also 0.2. So then this is the positive, this is the negative terminal. So the potential here, which I can say this as 0.2 into R. Now, so from this, what we can say now, the cell is charging or discharging. The cell is discharging. Cell is discharging means the cell will deliver energy. That E is equal to what we can say, tell me. So this is V plus R into I. So that is E value given 1.08, which is given as 0.6 plus R value given as what, tell me, 0.2 into, sorry, so I value 0.2 into R. Simplify 1.06 minus 1.08 minus 1.08 minus 0.6 by 0.2 is equal to R. No? So simplify, get the value of resistance. How much will come? 2.4 ohms. Next one. When two cells, each of EMF 2 volts, are connected in series, combination of two resistors 3 and 6 are in parallel. Terminal voltage of the battery given as 2 volts. The internal resistance of each cell is. They are saying that two cells are identical cells. These two are connected in what, tell me now, series. I have two cells. The two cells has been connected in series. This is EMF which is given as 2. The resistance not mentioned. So this is 2 volts and this is R, we don't know. and this has been connected to the parallel combination of two resistors, that is one is 3, the other one is 6. 3 and 6 are connected in parallel. If they are connected in parallel, so you can see now here this is 3 and this is 6. We can find the equivalent resistance of this part. They given this is the terminal potential. They given this is a value which is given as what, tell me? Potential which is given as 2 volts given. Now we'll combine these two here. First of all, we'll find the effective EMF. The effective EMF which is given as 2 EMF are connected in series. So this value will be a 4 equivalent resistance. That is what we can say now. This is 2R, and the external resistance which is equal to what, tell me now here? So this is 2. Now from this they given the terminal potential is given as what, tell me now here? 2 volts. We can get the current which is equal to what, tell me now here? 1 ampere. So since the cell is supplying the energy, what we can say now, the tell me now here? Cell is discharging. E is equal to what I can say, tell me? V plus R into I. We need the internal resistance only, right? So here E means effective means how much is value? 4. V value how much here? This is 2. And R means RE, that is 2R. And how much is current is 1. So that is 2R equal to 2. That is R equal to what, tell me now here? 1 ohm. Internal resistance is how much? 1 ohm. Next. A car has a fresh storage battery of EMF is given as a 12 volts and internal resistance is given. If the starter motor draws a current of 80 amperes, the terminal voltage is. Now what they given now here? So this battery EMF is given and internal resistance given. So this EMF, how much they given, you tell me? 12 volts. And this internal resistance R is how much, you tell me now? 2 into 10 power minus 2 ohms. And they has connected to a starter. So they are connected to a, this is the starter circuit. They are connected, this is some starter circuit. Right, so this current flowing through this starter is given as what, tell me now? 80. The same current will pass now here in series connection. Now they ask him to find the terminal potential. So the battery is delivering the energy. So battery is discharging. So EMF which is given as what, tell me? V plus R into I. So the terminal potential which is given as what, tell me now here? E minus R into I. So that is V is equal to E value how much? 12 minus R is 2 into 10 power minus 2. I value how much, you tell me now? 80. So V value will come it as what, tell me now here? 12 minus 16. 160. That is 1.6. So V value how much will come, you tell me now here? 8.4. Next, find the EMF and internal resistance of single battery which is equivalent to the combination of 3 batteries shown. Right. Now first of all we'll talk about these two cells. How these are connected? These two are connected in parallel. So then what type of connection now here? Aiding or opposing? So here both currents are same direction. This current, same direction now. So means the two cells are in aiding. So which is called as what, tell me now? Parallel aiding. This is called as what element of parallel aiding. In case of parallel aiding, so you can see now here uh, effect to EMF. So this is given us two case now here, which is given as E1 R2 plus E2 R1, that is E2 R1 by what I can say, tell me, R1 plus R2, 1 plus R2. So how much this effect to you tell me now here, which is equal to E1 R1. So that is 10 into 2. So this is 20 plus E2 R1. So 4 into 2, this is 8 by R1 plus R2, 4. So which is given us what we can say here, 28 by 4. So we'll come it as what tell me now, 7. 7. And what is the equivalent resistance? You tell me now. Two resistors now, R1 R2 by R1 plus R2. So we'll come it as what, tell me? So 2 into 2, 2 ohms. Now we can redraw this part of the circuit as like this now. Now this is this cell, and so this has an internal resistance of 1. This is the another cell, new equivalent value. This is, and it has a resistance now. How much this value? 2. Now we need to find the equivalent of these two here. So we need to find the equivalent of these two. So how this value? 1 now. R1 R2 R1 plus R2. How much this value? 1. Parallel now. So this value is what, tell me? 1. Now here series connection. So aiding now here, this is what type of connection? You tell me now, series aiding. So this is now it is series aiding, series aiding. So that's why effect 2, which is given as what we can say, E1 plus E2. 7 plus 6, that is what tell me now here, 13. And resistance is what tell me now here, 2. So what's the option you can see? B. Next, 100 cells, each of EMF is given as a 5 volts and internal resistance is given as 1, are to be arranged so as to produce maximum current in a 25 resistance. Okay, each row is to contain equal number of cells. Okay, equal number of cells. The number of rows should be, yes, to have a equivalent. So here for maximum power, the condition across capital R, the condition is what, tell me now here. So this is now here, this load resistance must be, this is capital R must be equal to equivalent internal resistance. Okay, so this value given as, so this across this element we should have maximum current means maximum power. Okay, maximum current means maximum power, right? So in these cases, this is the condition you can see now here. This is capital R given 25, so internal resistance must be also equivalent, internal resistance must be 25 we should get. Now you can see the things now, what type of connection I have to made it now here, 100 cells. So if I connect now here these cells, each will have a resistance of what, tell me now, 1. Each resistance is 1, like this we have connected. Like this we have connected. So here each one, the potential is 5, the resistance is what, tell me now, 1. So 5 volts and this is 1, like this we have connected. Let us say in this row we have connected 50 have connected. 50 connected. So then effectively this value will becomes what? Tell me now here. Potentials will be added. So 50 into 5, 250. And the resistance will becomes what? Tell me now here in this branch. So resistance will becomes so here 50. Resistance will become 50. We should require 20 now. So again I will take another same this situation. So if I connect like this, 50 we have connected like this. If I did the connection like this, 50 we have connected. All these are connected to the external supply. So this is 25. Now here as a result, in this case, this is 5, this is 1, like this. How many these are? These are 50. 50 cells. In this also 50 cells we have. So equivalent resistance of this part is how much? You tell me now. 50 ohms. And this is 50 ohms. And these two parallel effectively will become 25 ohms. So then this, so here it will satisfy now here external resistance is equal to equivalent internal resistance. Then we have a maximum current, then we have a maximum power will takes place. So how many rows are there? So this 1, 2 rows only now here. Each row contain how many? 50 cells. Each row contain 50 cells. Next, find the equivalent EMF and internal resistance of the circuit arrangement. Tell me the equivalent resistance and internal equivalent EMF. So we have more than 2 are connected. So effective EMF, which is given as what? Tell me now here. E1 by R1 plus E2 by R2 plus E3 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3. So effective EMF, what I can say here? So we can say this as 10 by 1 plus 4 by 2 plus 6 by 2 by 1 by 1 plus 1 by 2 plus 1 by 2. So this is effectively, which will come it as what we can say here, 10 plus 2 plus 3 by 1, 2. So how much this effective EMF will come here? 15 by 2 means 7.5. Resistance is what we can say here. 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. So this is 1 by RE, which is equal to what? Tell me. 1 by 1 plus 1 by 2 plus 1 by 2. So this is 1 by RE is equal to 1 plus 1. So this is RE. How much is value? 1 by 2 point. Next one. Two cells A and B of EMF given respectively are arranged as shown in the figure. The voltmeter reads 1.45 volts if the voltmeter is assumed to be ideal. Which cell has the higher internal resistance and how many times? Which cell has a higher? We need to find it. Right, they given the terminal potential is given. How much is value given as a 1.45. Right. Now you can tell me now here terminal potential. Yes. Arranged as shown, the voltmeter given us like this. Which cell has a higher internal impedance? So here first of all we'll find equivalent equivalent of these two, the two cells has been connected in parallel. Now here we can find out this value, effective EMF, which is given as what, parallel connection. Now here what we can say, tell me, two are there, parallel connection means what we can say, E1 R2 plus E2 R1. What I can say, tell me now here, R1 plus R2, right? So this effective, so which is given as E1 R1, E value which is given as 1.3 into R1 plus what, tell me, E2 1.5 into R2 by what, tell me, R1 plus R2, right? So this is the effective, and they given as what, tell me now here, RE, which is given as two are parallel, so R1 R2 by R1 plus R2. Now the final equivalent circuit, it will become like this. E effective and this is R effective. Now here they has connected the voltmeter, they connected. Here they connected the voltmeter. When they connected the voltmeter, so then voltmeter will have a resistance is infinity. Voltmeter will have a resistance is infinity. So as a result, then what happens, tell me now, the current R, which is resistance of this voltmeter, is how much, infinity. The current through the circuit, which will becomes what, tell me now, I value 0. So what we can say now here, effective EMF, which is given as what we can say here, terminal potential plus RE into I. So how much is I value 0? I value 0. So E means how much we have now? This is E, which is equal to V plus I value 0. Now you can tell me now here, effective, this is what I can say, 1.3 into R1 plus 1.5 into R2 by, so that is R1 plus R2. The V value given us what, tell me, 1.45. So then cross multiply and simplify this thing. 1.3 R1 plus 1.5 R2, which is equal to 1.45 into R1 plus 1.45 into R2. Next, this is 0.05 into R2, which is equal to what, tell me, 0.15 into R1. So means what we can say now, this is so this is, if you bring this thing to here, this side, so what will come here, R1 R2 relations will come, 2 zeros will get cancelled, that is 5 R2 is equal to what, tell me now, 15 R1 now. One second, हमने थोड़ा गलत किया इधर. So here this is even 1.3 into R2 plus 1.5 into R1 by R1 plus R2. हमने उल्टा लिखा इधर. Careful here. So this is what will be 1.3 into R2 plus 1.5 into R1 by R1 plus R2. So it is 1.3 into R2 plus 1.45 into 1.5 into 5 into R1 is equal to 1.45 into R1 5 into R2. So this we can bring, this is 0.05 into R1, which is equal to 0.15 into Yes. So this is, what tell me, R2. So this is 5R1, which is equal to 15 R2 now. So this is R1 is equal to 3 R2. Okay, fine. Yes. Okay. Yeah, that's for the today's session. And the next session we will discuss the some more problems. Okay then, see you. Bye bye.